Good morning to everybody. We are discussing about the elastic behavior of elastic materials. Study of matter. So you know what is matter? Matter means it occupies space and also has some mass. That matter will exhibit different characteristic properties. So there are so many properties relating to the matter if it is exist as a solid, liquid or gas. So we are discussing about the properties of matter in the form of solids. So you know what is solid? In the case of the solids, the molecules are arranged very tightly packed together. The intermolecular space is negligibly small and the force of attraction between them is very high. And these matter exhibit so many properties. The first one is that elasticity. And also it possesses the property of plasticity. And also it can exhibit the property of brittlity. And there are so many properties exhibited by the materials. But here we are discussing about the property of elasticity. Elasticity means it is a property of a material body to regain its original state after the removal of the deforming force. You know what is deforming force? The force which is used to deform that body. That deformation takes place either length or position or its volume. There are so many changes. The length of the body may change, the volume of the body may change, or the position of the body may change. So that deforming force acting on unit area is called a stress acting on the body. So the stress is defined as the force acting per unit area. Because of the deformation or because of the deforming force, there is a change of this body. That deformation may be either length or volume or its position. So there is a very important relation between this stress and strain. So what is strain? The stress and strain are directly proportional. Strain means when the deforming force is applied on this body, what deformation will take place? So that deformation is called a strain acting on this body. So strain is defined as the ratio of change in dimension to the original dimension. So there are three types of strains are produced. That means linear strain, volume strain and shearing strain. The important relation between stress and strain is established by the scientist namely Albert Hooke. That law is called Hooke's law in elasticity. So according to Hooke's law, we can say that stress is directly proportional to strain, but that is within the elastic limit. So within the elastic limit, the stress acting on a body is directly proportional to the strain. Therefore, stress is equal to a constant E into strain. So where this constant E is called a modulus of elasticity, that is obtained by E is equal to stress by strain. There are three types of elastic moduli relating to the linear strain, volume strain and shearing strain that are denoted by Young's modulus of elasticity, bulk modulus of elasticity and rigidity modulus of elasticity. And the relation between stress and strain always represents by a straight line. If you draw a graph relating to the stress and strain, the graph starts from the origin. The stress strain diagram is a straight line which shows that it is a straight line up to the elastic limit. So within the elastic limit, we can say stress is directly proportional to the strain that is established by the scientist namely Sir Albert Hooke, which is called Hooke's law.